Lesson 17.2, Task 4. Solve real-world quadratic equations. Tia is contracted to expand a rectangular deck that currently measures 10 feet by 6 feet. Two sides of the deck are up against the house. Tia plans to increase the length and width of the deck by the same amount so that the deck's new area equals 165 square feet. By how much does she need to increase the length and width of the deck? All right, so in the picture you can see that the length is 10 feet and the width is 6 feet, and we're trying to find out how much larger or how much more area it needs to have to equal 165. All right, so you can see that they're looking at, here is the deck. And we don't know how much we need to expand it. That's what we're trying to find. So we're going to expand it by x, and we're going to expand it by x. So we're going to have to solve for x. All right, to verbally model this, that means we're going to increase the length by x, so x plus 10. And we're going to increase the width by x, so it would be x plus 6. And we need the length times the width to equal 165. So in order to do that, we would have to write it in parentheses because remember, area is length times width. So if area is length times width, and then we have this, our length is now x plus 10, and our width is x plus 6, and we know that we want that to equal 165 square feet. All right. Why is it important to place grouping boxes around the new lengths and widths? Okay, so what they're asking basically is why did we put parentheses around this? Knowing that the area is length times width, if we don't put parentheses around it, then it would represent something completely different. So just knowing the formula, length times width, whatever the length is has to be multiplied by the width. Since we're trying to expand the length by x, and we're trying to expand the width by x, that is part of that number. We just have to figure out what the x is, okay? So parentheses are very important in this case. All right, so it says write an equation, okay? We've done that. And it says, why can't the zero product property be applied here? Well, remember the zero product property says you have a product equals 0. That's why it's called the zero product property. This is not equal to 0, so we're going to have to do a little bit of work to this equation before we can use the zero product property. So it says the zero product property can only be used if one side of the equation is a product and the other side of the equation is equal to 0. So we have the product, but it's not equal to 0. All right, so it says solve the equation. Okay, so we're going to solve the equation. So basically what we're going to have to do is start by putting the left side in standard form. So we're just going to distribute these, multiply these together. So x times x is x squared. X times 6 is 6x. 10 times x is 10x. And 10 times 6 is 60. All right, once we do that, we have like terms that we can combine. So we have x squared plus 16x plus 60 equals 165. Now, if we want this to equal 0, we have to subtract 165 from both sides. So we have x squared plus 16x. 60 minus 165 is negative 105. And 165 minus 165 is 0. So now we have it set equal to 0. All right, so now we have to factor. It was factored, but it wasn't equal to 0. Now it's equal to 0, and it's not factored. So we are having to do a few extra steps because it wasn't set up in the correct form, but that's okay. It's a real-world problem. We have to solve it. So now we want to rewrite this in factored form. So what are our factors going to be? So what we have to do is look at what multiplies to give us C. In this case, C, remember it's ax squared plus bx plus c. We have to multiply to get C. and we need to add to get 16. So we need C equals negative 105 and B equals 16. So we're looking at our factors of negative 105. So we're going to have 1 and 105, and then 2 doesn't go into it. 3 goes into 105, so 3 goes into 9 3 times, and 3 goes into 15 5 times. I'm trying to think here. All right, so 4 doesn't, 5 does. 5 goes into it 21 times. 5 times 20 is 100, so I know 5 times 21 is 105. Again, being able to factor, you should have a good sense of numbers, like how they multiply and add together. It really helps when it comes to factoring. And that's something you can always practice as you go along. All right, so I know that 5 and 21 are 16 apart, and when they multiply, they get 105. Now, I do need a negative 105, so one of these has to be positive and one has to be negative. To have a plus 16, the bigger number has to be positive. So I'm going to have negative 5 and plus 16. And again, you can always check that. Wait a minute, where did I get 16 from? I wrote the wrong number down, 21. All right, so I want negative 5 and plus 21. And together, the middle terms will add up to give me 16. That's where I got my 16 from. All right. Now it says, what strategies could you use to factor? Okay, so we just factored it. Select the phrases to complete the statement. You could list the factor pairs of 105, negative 105, and find the pair that has a sum of 16. All right, so that's what we did. We found the numbers that multiply to give me this and add to give me this. All right, why doesn't the negative solution make sense in the context? Okay, so if I solve these, okay, zero product property says we can take these factors now, set them equal to 0, and that's how we get our solution. So we're going to get x equals 5, and if we set this equal to 0, I subtract 21 to get x by itself, so x equals negative 21. So if you remember, we're talking about length times width. So length can't be negative 21 feet, and width can't be negative 21 feet. So in this situation, negative number does not work. So that means our x is going to be 5. So this question is saying, why doesn't the negative make sense? The length or width of the deck cannot be negative. That's true. You cannot have a negative variable. Sometimes you can. Not often, but sometimes you can have that. And the value of x must produce factors of the original equation. That is true. And the value of x was meant to represent an increase in dimension. That is correct, because remember, we're increasing the size of the deck. All right, so down here it says Tia should increase the length and width of the deck by 5 feet, so the new dimensions are 15 by 11. Okay, so if you remember, the original was 10 and 6. So the deck was 10 feet by 6 feet, and they're saying we're going to increase it by 5. So 10 becomes 15, and 6 becomes 5 plus 6 is 11. All right, and then you want to check that. And you know that we wanted 165, so 15 times 11 equals exactly 165 feet squared. All right, so again, remember the dimensions of the deck we started with were 165 feet. All right, if you have any questions about task 4, let me know.